Alright, so we're still talking compositions, but this time I'm going to change things up a little bit. F is actually a quadratic function in equation form. T of x is a linear function in equation form, but then we have a function that's given in a table, and then we have another function that's a pretty complicated looking graph. So how do I do compositions when I'm given a bunch of different types of functions? We've already seen how we do it when we have functions that are nice in equation form, but how do I throw in some things or tables and graphs? Well, the first thing we need to do is we need to realize that it's really hard to actually come up with a function of x like we did here and here. So because of these guys, what we're actually going to be doing is looking for values, and that's the only way we can really do this. So that's what's going to change from this worksheet as opposed to the other. So notice, right, we're actually finding a value. So my new function f composed with t, what's its value when the input's 1? Right? My new function f composed with g, what's its value when the input's 0? And on and on and on. So you notice I'm using some values to find that. So we start this by doing the same thing that we did, right? What does this mean? Well, this means f of t of 1. So the first thing I got to go do is find t of 1. So t of 1 for the function that I have is 3 minus t, 2 times 1, which is 3 minus 2, which is 1. So this becomes f of 1 from the work above. And then how do I find f of 1? Well, since it's given in equation form, I just plug it in, and we're off to the races. So this is 2 minus 1 minus 3. It looks like, what do we get there? That's 1, negative 2. All right? So this evaluates out to negative 2 for the functions that are given. All right? So again, we're taking a value and putting it inside of another value, or another function, but I got to find that function value first. So what about f composed with g of 0? Well, in practice, this is f of g of 0. So I got to go find g of 0 somewhere, right? And it's given as a table. So when x is 0, it looks like g of 0 is 5. So this becomes f of 5. How do I find f of 5? Well, since it's given in equation form, we just plug that value in and then evaluate. So one, we can just read the table. For the other, we do a calculation. So I think that's 50, and that's going to give us 8. We're getting a value of 42. So this evaluates out to 42 for the functions that are shown. Okay? And so the next one, again in practice, this is f of h of 4. So I got to begin by finding what is h of 4. Well, h is given as this table. So when x is equal to 4, it looks like the corresponding y value to me looks like it's negative 1. So we're basically looking at f of negative 1. So how do I find f of negative 1? Since it's given as a function, right, a nice equation, we just simply plug our value that we have. That's going to give us a 2 plus a 1 minus 3. I think we get 0 out of that. So for the functions that are given, f composed with h of 4 evaluates out to 0, and we're done. So please make sure you're showing that preliminary work, all right? Somehow, some way, you got to tell me, either evaluate it out or you read a table, letting me know that you understand what's going on. So keep on going. We have h of g of negative 1. So how do I find g of negative 1? I go read the table. When x is negative 1, it looks like the output is 0. So g of negative 1 is 0. So we're looking at h of 0. How do I find h of 0? Well, when x is 0, it looks like the output is a negative 4. So for the first one, we read a table, and for the second one, we read a graph. Putting it all together, it looks like h composed with g of negative 1 is negative 4. What if I reverse that, right? This is g of h of negative 1. Well, going and reading my table at negative 1, it looks like the corresponding output, oops, you know what, I think I screwed up. That should have been a negative 3. That should have been a negative 3, because here it looks like h of negative 1 is negative 4. I apologize for that. So this is g of negative 4. So what's g of negative 4? Well, when the input's negative 4, it looks like our output's negative 5. So this evaluates out to -5. Okay, so we're just reading tables as we go along. F composed with itself of 1. So what's f of 1? Well, f of 1 we can find by plugging in. So we get 2 times 1 squared minus 1 minus 3. This is 2 minus 4. So this is f of -2, right? And so what's f of -2? Well, if we plug it into the function like we did before, right, we get our value. And so I think that's 4. This is 8 plus 2 minus 3. We're getting a 7 out of that. So f composed f of 1 is equal to 7. And you just kind of keep this going. So what's h of -7? Well, it all begins by finding what is h of -7. So when I come, there's 4, 5, 6, 7. It looks like the output is 2. So we're looking at h of 2. So coming back to my graph, when x is 2, it looks like the corresponding output, I'm roughly estimating that's -4.5. So that looks like a pretty good estimate of what happens when we compose h with itself and plug a -7 into there. Okay, and then h composed with t of 6, well, that's h of t, oops, let me write that better. That's h of t of 6. So we got to go find t of 6. So t of 6 is 3 minus 2 times 6, which is 3 minus 12, which is basically, is that -9? So we're looking at h of -9. And so when I come over here, when x is -9, we run into a problem, right? Because -9 is actually not in the domain. So that can't be found. This would be undefined. And we're getting to a very important topic here about domain of a composition, because we have to make sure that when I pass the value on to the next function, that the next function can actually handle it. All right, so again, if you think in terms of an assembly line, if I heat a plate up to 500 degrees, I got to make sure when I hand that plate off to somebody that they can actually handle that hot plate. If they can't, then we can't go any further down the assembly line, and that's kind of what happened here. So putting 6 into t was fine, we got a -9, but passing that value on to h has a problem with it. It's not defined for -9. So we got to be careful. It kind of restricts the domain, and I'm kind of getting on the next topic, but we'll get there when we get there. Last but not least, g composed with f of 0. Well, this is g of f of 0. So we got to find f of 0. So when I plug 0 in there, f of 0 is 2 times 0 squared minus 0 minus 3. We get -3. So we're looking at g of -3. So going to my function g is defined as this table. When I look at the x values that are given, right, -3 isn't actually an input. So again, we have a domain problem, and so that just simply means this is undefined. So even though f can start things off, when it tries to pass its value on to g doesn't know what to do with it because it's not in the domain. All right, so that brings us to the domain question that we'll consider in the next video. But hopefully that, I think our first round, we built new functions from old ones, got functions of x. Here what we're doing is we're evaluating compositions. So you just basically pass one value on to the next, and you just keep finding finding outputs for given inputs, and you just keep building on that over and over and over again. All right, so let's go take a look at domains. We'll cut to a new video.